Okay, maybe we should
Actually, that's what we want.
Nederland is volgens mij nog een halve verder.
Ja.
Ik krijg het verder dan maar
Oh ja.
gewoon een nieuwe.
Ja, voor mij staat het eigenlijk bij centraal of inderdaad springen pakken en dan vanaf Nederland.
The largest online retailer in the Netherlands and Belgium, Bolcom, and I'm here today to talk about how we tamed our huge Angular applications with modern repositories, design systems, and web components. And first of all, let me introduce me a little bit further. I have a master's degree in archaeology, love to play sports. My main sport is water polo, hence my answer to Tom's questionnaire.
Nice. Ah, that was you.
Yep, that was me. Guilty. Alright. Love to read books, and I occasionally jump out of planes with a parachute at this, otherwise I should be here. Yes, and as befits a true archaeologist, let me start with my story right away with a small college on the history of the company I work for. It all started back in 1999, where Bolcom launched as a small web shop where people could buy books and CDs from. And well, right from the start, it had some success, and we soon realized that other products were perfectly capable to be sold online as well. So in the following years, we extended our assortment with all kinds of products like sporting gear, home appliances, gardening tools, well, you name it, and we tried to sell it online. Until a certain point, and that was in 2011, that we couldn't cope with demand anymore. And that was, of course, a huge problem for us, a huge challenge. But because basically we were losing money and we couldn't serve our customers anymore. So we had to come up with something new, and we had to come up with something fast. And that's when we decided to transform the web shop into a shopping platform and welcomed third-party sellers to sell, to add and to sell their assortment via us. And it was an instant hit because in 2013 we reached our 1 billion turnover point. But with everything, this had its challenges as well, because the seller's assortment didn't appear magically on the web shop. We wish it would, but it didn't, unfortunately. So we had to build tools for them, to enable those sellers to add and maintain their assortment. So a small development team was dedicated to the task, and they basically formed a small startup inside the company. And in the true spirit of a startup, they started to build a monolith. And what's a monolith? Well, a monolith is basically one big application that contains of a server-side app where the business logic lives, a backend, so to say, a user interface. This is basically the front end, and this is where the user is able to communicate with the backend, and a database where data is being stored in. Well, even back then, this technology, this monolith, was considered as ancient technology, as a relic to the past. But for a small development team that needs to deliver fast, it actually made sense to build a monolith, because you have less cross-cutting concerns. Every feature you build is contained in one and only one application. So you don't have, you have lesser dependencies with other applications. Same goes for the operational overhead. You aren't as dependent on teams with a monolith. It's quite performant as well, because every feature in your application has access to the same shared memory. It's quite secure as well. There's room for discussion here, but it's quite secure as well, because you only have to monitor one single application. And planning and designing new features is quite straightforward. But as I told you before, well, the selling platform became quite a success, and more sellers joined, so we had to scale up. So more teams were assigned to this project, and slowly all those advantages turned into disadvantages. Because having a monolith means that you only have one single code base. And sometimes it's already challenging to maintain a single code base with one team. So just imagine maintaining a single code base with multiple teams. Well, that's quite hard, and to be honest, it's a huge challenge, if not impossible. Same goes for less operational overhead, because you suddenly have to communicate with all kinds of other teams. And I know as IT engineers, as software engineers, sometimes communication is not our strongest point. So yeah, less operational overhead could backfire enormously. Well, performance as well. Multiple teams are adding more and more features to the application, which making it more complex. And that has its influence on the performance of an application as well. And sure, you can scale up your hardware, but only till a certain point. And if you exceed that threshold, yeah, your application will perform less. Same goes for security. Complex applications are less secure. So if you keep introducing new features and well, automatically introduce more bugs to an application, it becomes less secure. And don't even get me started on planning and designing new features for such a complex application. So in order to be able to scale up again, we realized that we had to change our architecture, our application architecture. So enter microservices. And what are microservices? Well, microservices architecture is basically an approach to create one single application out of a collection of small microservices, micro applications. So what we basically did is chop up our complete monolith in single tiny little services. And one of the features of a microservice is that every service has its own single feature, its own single cost. So we split up the backend of the application in countless microservices, and we did the same for the front end. But how can you split up a front end into microservices? Because you can't split functions into microservices. No, you split up flows, application flows into so-called micro front ends. So for example, if you have a login flow or a seller wants to check his assortment, that could be a separate flow as well. Or if a seller wants to adjust his prices, that can be a flow as well. Well, all those flows are contained in single micro front ends. And this approach brings us lots of advantages. For example, scalability. If we want to add a new feature, for example, it's basically creating a new microservice for that, expose a public API, and publish it to our application landscape and connect it, and presto, we have a new feature. Same goes for independency. I told you before, in a monolith application, every team had to collaborate and had to work on the same code base. So that was quite troublesome because it jeopardizes the independency of the teams. And at Bol, we really value autonomy, and we really believe that autonomous teams are more performant than, well, dependent teams. So it's really good for the independency as well. And the same goes for the transparency, since every microservice has only one single purpose. So it's quite straightforward to see and to find out what a particular service is doing. But as an application scales and more features are added, well, all those advantages slowly turn into haha, yes, correct. And let's take a look at this picture. So, who knows what this is?
Is the Bolcom landscape of microservices?
Almost. It's Microservices Dead Star, and it resembles. Can you recognize the Dead Star? Here's a little eye and, well, a circular thingy. Yeah, this is the Microservices landscape of Netflix. And, and as you can see, every green point and every orange, every gray point is basically a microservice, and every blue line is a connection between them, a dependency between them. So be aware that a microservices landscape has its disadvantages as well and can grow quite complex, as you see here. And there's another huge risk, so to say, and that's consistency. While having this is consistency in the front end of a microservices application. Well, if you compare it to the front end in a monolith, there you have just one front end basically, and it's quite straightforward to keep that consistent. But in a microservices architecture, the front end is being chopped up in countless micro front ends, maintained by several other teams. So it's quite a challenge because every team has their own way of working, might have different technologies, are using different tech stacks to keep that consistent. And we were facing this problem at Bol. So we had to come up with a solution for that. And we found a solution in a design system. And what's a design system? Well, the design system is a collection of reusable UI components. You can compare it with Lego building blocks, accompanied with clear guidelines, clear instructions, which enables you to create and recreate any number of applications you want. And a design system consists out of three items, three parts, basically. The first one is a pattern library. The second one is the style guide. And the third one is the components library. And let me elaborate on that. The pattern library. As a developer, I want to know how, when, why to use a certain component, a certain building block. And that's what I find in a pattern library. Take a button, for example. If a button comes in many flavors, we have a primary button, we have a secondary button, we might have a tertiary button, or an outline button, or a whatever button. And as a developer, I want to know when to use a particular flavor of that button. And that's what I find in a pattern library. Next, we have the style guide, and this is basically a technical description of your brand's identity. So in the style guide, you can find your color palette, as we can see here. This is basically a sauce file, containing all the colors the teams can use to build their applications with. But you can also find your headings, your typography, so which fonts you can use, which spacings between paragraphs or between headings are being used, etc., etc. So this describes your brand's identity. And last but not least, we have a components library, and this is where all the components live, all the Lego blocks live. But before I take a deep dive into the inner workings of the components library, let me tell you, let me give you another college on the teams at Bolcom and earlier attempts of building components libraries. At Bolcom, every team is completely autonomous and is completely free to pick whatever tech stack they feel most comfortable with. And besides that, they also have their own way of working. So back in the day, and I'm talking about 2011-ish, AngularJS was the bomb. It was the framework to be. So it made complete sense for all the teams to build their applications with AngularJS because, in the words of Tom, it was really, really cool to use and very convenient as well. So, and for us, it made complete sense to build our first components library with that framework as well. Because, everyone was using it and, it worked for a components library as well. Let's do it. Cool. But then, Angular came out. And it was, as you might know, completely breaking with AngularJS. It was a completely different framework, despite the name. It's quite similar, and it's quite confusing as well. Teams were already using it, experimenting with it, and eventually they start building their applications with it. So now we have a problem because we have legacy applications. We have a legacy components library that is incompatible with the newer applications. So we've decided to port our components library into to Angular. Big problem, and with hindsight, we thought that the AngularJS application would be migrated soon anyway, so we should get rid of it quite fast. But until this day, we still have AngularJS applications running, and yeah, suddenly we had 2 components libraries to maintain. Very nasty. And other teams were experimenting with React and vanilla JavaScript as well. So in theory, we had to support them with our own port of components library as well. Undoable. And this because we locked ourselves into Angular. So we had to come up with a solution for that, because eventually, who knows what's next? We would need to maintain countless components libraries. So our answer was, after some intensive research, we found our answer in web components. And what are web components? Well, web components are basically a collection of 4 web standards, 4 web standards APIs, that allows you to create your own custom HTML elements with. And let me elaborate on that as well. The first one is the Custom Elements API, and this allows you to extend existing or build completely new HTML elements with. And you do that by extending, by creating a standard ES6 class that extends the HTML element base class. And that HTML element base class is part of the Custom Elements API. And this is where, in that class, is where you define your components logically. Next, if you done developing your component, you need to register it to your browser's Custom Elements Registry. And this is basically where all the HTML elements live. And, well, you basically need to say to the browser, hey browser, I made this fantastic new component. Please accept it as just another HTML component, element. And after registering, you can use it anywhere in your application, like that. So pretty cool, that Custom Elements API. Then the second one, this is basically the simplest one. It's the HTML Templates API, and what it does, it provides you with a template tag. Pretty straightforward. But the cool thing of the template tag is that all its content, so all what's in between those template tags, isn't being rendered on startup. So when your application starts or when you visit the page, that button won't be rendered. So this makes it ideal to use in custom elements, because you can clone this template and reuse it anywhere you like. So you can render this with JavaScript. Then the third one, with the coolest name, that's my opinion, the Shadow DOM. And one of the challenges is in building a components library is that you don't want to have your components leak styling or leak functionality to its host, to its application, and what it's used in, and vice versa. So you need a way to confine your component to confine your component, and that's where the Shadow DOM comes in. Tom already explained what a DOM is. Well, a DOM is basically a tree with HTML elements, and everything is accessible in that tree. But what a Shadow DOM does is create its own separate subtree that is only accessible by a component, for example. So this is really useful. I think this is the most important one, most important API with web components. And last but not least, we have the ES Modules API, and I think this is the most familiar one. And the ES Modules API basically allows you to create small pieces of code or classes or modules, so to say, that you can use and reuse anywhere in your application. Like for example here, we've created a class animal, which contains a constructor that accepts a property name, and then we have a parameter name. Then we have a property name which gets the value of that parameter, and we have a method greet. which returns a greeting message with a value of this.name. And if I want to use it anywhere else in my application, I simply import the animal class from, well, wherever that thing lives, and we can create a new instance of it with a name, and then we can make the animal greet us. Well, in this case, it will result in, hello, my name is Mr. Mittens. So really cool. So we were quite convinced that web components are really helpful to us, and it was the technology of choice of our developers, because it makes us extremely flexible. We don't have to worry about framework logging. It's interoperable because it just works in any browser. It's consistent because of the shadow DOM. You don't have to worry of styling and functionalities leaking in or out the components. But with anything great, you always have downsides as well, or disadvantages, so to say. And that's the development speed. And I will show you that in a minute, because it's quite cumbersome and complicated to create web components. And last but not least, browser support. So what is said with interoperability, okay, say it with polyfills. But let me give you an example how hard, how complicated it is to create a web component. Well, I hope this pointer will, yes, haha, awesome. Okay, this is the web component that I want to create today. So it's just an extended button. My button, and the rest is some markup. So this is what we want to create. The first step is to create a template. So, well, we open the template tag, we give it an ID so that we can refer to it later. We add some styling here. We create the actual HTML template and we close it. Pretty straightforward. Then we extend the custom HTML element base class. We define a constructor. We create a reference to the template. And then we initiate the shadow DOM. And this is how you do that. So you attach the shadow DOM to this class and you append the template. We're cloning the template here, like I said before, and append it as a child to this class. Really cool. Okay, then we need to define a custom element in a custom elements registry. And there we are, we can create it. Well, it looks pretty straightforward, but it isn't. It's pretty straightforward, but this component is a really simple component. And we didn't thought about testing, we didn't set up a development server, we didn't think about polyfills, for example. So, well, this took us like half an hour to build on average. And that was quite troublesome because we had to build a complete components libraries with countless components in them. And yeah, we wanted to test them properly, so yeah, eventually if we want to go through with this, we had to set up, or we have to spend weeks to setting up a proper development environment and make it all work. So it was back to the drawing board for us. And because we were really convinced about the workings of web components and the advantages that they bring, but yeah, it troubled us. So we start our research again, and eventually we ended up with Stencil. And Stencil is a web components generator that generates 100% native web components. So that's really cool, so we have all those advantages. And it adds synthetic sugar to the development process. It's quite performant as well because it has a really small API. Aha, there we are. It's future-proof, web components. And it's compatible with all major frameworks out there. So it's Angular friendly, it's React friendly, it's Vue friendly, and you can even use it in your native vanilla JavaScript applications as well. So let me show you how to build the same components like before, but then with Stencil. Well, the neat thing with Stencil is that it comes with a command line interface. So you just have to open a terminal and enter npm init stencil, and it will automatically show you a dialog. So what do we want to build today? I hope it's readable in the back.
Yeah.
Yeah?
Yeah.
Cool. Okay, so, well, we want to build a component. So we choose for the option component. And then it automatically generates in under 4 seconds a complete professional development environment with testing included, polyfills, a build street, whatever you want. And this is how it looks like. So we have a component living here. We have a separate CSS file. We have a test file, end-to-end test file, and we have a component file. And well, as you can see, we have some configs here. We have some typings as well. I'm not sure, is anyone familiar with TypeScript? Okay, cool, cool, cool. So typings are automatically generated as well. And well, it basically provides us with everything we need. Awesome. So when we first tried this, we were, well, our minds were blown because it was so awesome. And under 4 seconds, well, we had a complete development environment. Okay, the next step we needed to take was, this is how a stencil controller looks like. And one of the great pros of StencilJS is that it takes the best of the React world and the Angular world. So the basic syntax is TSX, so JSX with TypeScript. And for example, this looks really familiar with an Angular component. So yeah, best of both worlds here. And as you can see, we need to define a tag, we need to define a style URL, if we want to use the shadow DOM or not. And here's where our template lives. So let me adjust that. So we adjusted our tag, our style URL, and we've defined a template. And now we just need to build it. So, well, there you have it. Just in the terminal, bam! Under 8 seconds, and that looks a little bit long, but let me elaborate on that later. We have a complete build. So we have a component here, polyfilled, tree-shaped, bundled, everything you need to, well, provide a modern component for modern web applications. And this is how you use it. So you just import it, and you can use it like any component there is. So this is the power of StencilJS, and it comes with an extensive config, bundling tools as well, like we saw. It comes with a dev server, so that's really convenient for our developers. Typed components, auto documentation generation. Well, that was insane. When we saw that for the first time as a feature, we were a bit skeptical because, yeah, you know how it goes with documentation generators. But we were quite excited about this one because, yeah, basically, thanks to TypeScript, yeah, Stencil's able to generate your documentation for you. So it describes your methods, it describes the properties, it describes the public API as well. So that was awesome. And plugins, for example, as well. We were quite fond of SOS and SCSS at Bolcom. And well, by default, Stencil comes with CSS. But with a simple plugin, it's a matter of seconds to install it and configure it. You enable Stencil or SOS with a Stencil. And last but not least, your build is automatically polyfilled and it's lazy loaded. So for example, if you want to use this component in Internet Explorer, well, basically the whole shebang on polyfills is being loaded. But if you want to use this component with Chrome or Firefox, where the web component standard is better supported, has better support, then well, it only loads the necessary polyfills. So awesome. So we were really convinced that we wanted to use Stencil to create our components with. But now that we have a solution for creating components, we need a way to store our components. And well, we were discussing this in the team because yeah, we wanted to publish our components separately. In the past, we just published one big components library to our local NPM repository, and it was okay if you want to use all the components in there. But if you only want to use one or two components in that components library, then you basically are bloating your application, and that was not very nice. So we wanted to publish them separately, and we had several approaches to do that. One approach was to create a repository, a separate repository for every component, but yeah, that became quite complex, and yeah, and it was not very convenient because you don't have a single source of truth, and that's what we want to accomplish with well, a components library as well. So we've decided to follow the lead of the big companies, the big tech companies out there like Facebook, Google, and Twitter, and decided to go for a monorepository. And what's a monorepository? Well, it's basically one big repository where you store, in this case, all your components in. And it's really convenient because it provides you with one single source of truth. Everything is in one single repository. The second advantage is its reusability, because you can reuse your components anywhere. Versioning as well, later on that, more on that. It's scalable, it's easy to expand, easy to extend, and you can build and thrive on the experience of the larger tech companies out there. So this is how our current components library looks like. Well, we have a source folder, we have some components, and we're currently using atomic design principles. Who's familiar with atomic design? So let me elaborate that for the rest. Well, atomic design is basically a way to organize your components or organize your applications. So, and it's based on the anatomy of well, basically humans or animals or whatever. So first, the tiniest parts are atoms, then you have molecules, and then you have several other steps. And well, and this is what we're trying to resemble here as well. But we use the analogy of Lego building blocks because there was a lot of discussion going on in the teams. Well, what's atom? What do we consider an atom? What component do we consider a molecule? Or is it a molecule in an atom or whatever? So we decided to make it a little bit easier and go for the bricks analogy. It was easier to understand and easier to comprehend as well. So this is where you see, and this is, well, with buttons, cards, containers, and footers. And those are our smallest components. And in the analogy of atomic design, those are our atoms. So, and like I said before, we want to publish them individually to our local NPM repository. And well, okay, having a mono repository is one thing. To publish them separately is another thing. And we needed some help from a little tool called Learner.js. And Learner.js is, well, it looks really creepy, but it's actually a very nice tool, very friendly, user-friendly tool as well. It's basically a repository manager, which manages versions of packages, and it basically takes the complete publishing process out of your hands. It does it all automatically and out of the box for you. So, Learner.js provides us, for example, with scoped packages. One challenge is, well, we have a local repository, but if we want to publish, for example, a buttons component, well, it has quite a generic name. And the possibility is that somewhere else in the company, someone published a buttons component already. So that will result in conflicts. Well, scope packages allows you to create a namespace for your library. And in this case, well, it's awesome components-lib. You see the same. And you can publish your components to that namespace. And as long as if you are using unique names for your components, well, you can publish it to your namespace, like we did here. The second advantage Lerner provides is semantic versioning, and you can see it here. And this is a convenient way of versioning your components. So, for example, if you have a minor fix or added a minor feature to it, you will increase the latest number at the so-called patch updates. If you have a slightly larger feature to add or to change, slightly larger change to your component, you just update this number here. And if you have a breaking change or a completely new version of your component, you're updating the first number, a so-called major release. So that's quite convenient to us because in the past with earlier attempts of creating component libraries, we didn't adopt semantic versioning, and well, that became quite a mess very quickly because everyone has its own interpretation of versioning. So, okay, and you have no interdependencies. It's like what it said. With the namespace, you prevent, well, buttons from, well, you're basically preventing conflicts. So, and adding new components to our mono repository, to our components library, is pretty straightforward as well. It's just as easy as creating a new folder, add it to your components. In this case, we want to add an icons component to our bricks folder, and well, Lerna handles the rest for you. So now we have a proper way to store, publish, and distribute our components as well. So to conclude my story, a design system is a great tool to maintain consistency and to tame huge enterprise Angular applications, but it's not the holy grail of consistency because it all starts with communication. A design system is a really neat tool, a really great tool to enable that communication, to make a common understanding between developers, UX designers, UX developers, and business stakeholders, but eventually you have to communicate with each other and align your processes. So that concludes my story. Are there any questions? I heard from a team that was working on the tools for years already, and they didn't know of the existence of the design system. So my mind was blown. Really asked myself how that was possible, but well, that is one of the biggest challenges. So adoption and yeah, communication. Did that answer your question? Sir?
How do you validate if the teams are actually implementing the patterns you describe in the components you envision how to use the components in such ways that they are meant to be used?
Good question. So the question is, how do we validate the teams, basically?
Yeah.
How
do you educate the teams?
Or educate the teams as well. Yeah, that's a nice question, and that's a very interesting one because well, we have an IT team in place that maintains the design system. So the team builds components and maintains the components and ensures consistency. No, it doesn't ensure consistency. That's what we have our UX team in place for. So the UX team is in charge of the complete design of the complete platform, of the tools we build. So, and in that sense, the UX team is responsible to ensure that the teams are using the design system as well. And one way is that the UX team is incorporating the components library in their designs, because that is one of the biggest challenges as well. UX designers really tend to want to be creative. They really want to be creative, and with a design system, they are a bit held back because now you have consistent components, and yeah, let's say less creativity as well. So yeah, they have to incorporate it into their designs, and you have to validate the designs the teams are implementing, or the end products the teams are building. Did that answer your question? Oh yeah, and education.
Do they actually validate the designs that are being implemented? UX team?
It depends. Mostly they do. Mostly they do, and it's starting to become better, but it's still a process, and yeah, we have still lots of things to learn. And regarding education, I'm tech lead at Bolcom and community lead for all the development teams who are working with the design system and who are building the tools. And well, we organize monthly knowledge sharing sessions, bi-weekly coffee sessions where developers have the opportunity to meet each other and to discuss and to share knowledge. So that's how we do that as well, and we're currently working on several workshops that teams can follow to help them to learn what the design system is, what it can do for them, and how to use it basically.
How many development teams do you have, and how many people are in your team?
Good question. So how many development teams we have? At the back office, or?
Yeah, for example, the back end and front end and DevOps.
Okay, okay.
How do you manage that? How many are they?
Good question. Well, at Bolcom, we have a distinction between the web shop and, well, the tooling section, so to say. And in total, we have around 100 development teams, both back-end and front-end. And I'm not sure how many back-end teams and front-end teams we have, but the majority of that are back-end teams. That's true. And at the back office, so at the tooling department, we currently have 15 teams and counting working on this application, or on this platform basically. Does that answer your question?
Yeah, I was wondering also what the average number of people are in the
Oh
team.
yeah, of course, sorry. The average number of people in a team is between 4 and 6.
I have another question.
Of course, of course.
Do they, when they make the feature and they want to deploy it, do they do that themselves, or do they have to like communicate through other people?
No, they do it completely by themselves. So every team, like I said, is completely autonomous and is free to pick whatever tech stack. But it means that, basically all our IT teams are DevOps teams. So they build a feature, they build an application, and they publish it, and yeah, they have to maintain it as well. So with great power gets great responsibilities as well. Itself, or?
No, I mean, what if a front-end developer creates a bug?
Yeah.
How do you guys handle it further? Like, do you have to like fix it themselves in a certain period of time, or like does it go through other phases? I don't know how you guys work.
Yeah, okay, yeah.
That's what I'm asking.
Okay, yeah, I understand. Well, it really depends on the team. Of course, every team needs to test their applications and the features properly. But of course, it can happen that a bug is being introduced. And yeah, when noticed, they have to solve it as quick as possible on their own. At Bol, we have a mantra: you build it, you run it, and you love it. So, well, you have to build it, yeah, you run it, and you have to maintain it as well. And well, if something is wrong with it, you have to fix it as soon as possible.
Right.
So it's all on the teams themselves. And of course, yeah, well, that's autonomous nature. So every team, how do you say it? every team fixes it themselves, but sometimes they don't notice when, if a bug is being introduced or if their application isn't working. So we have plenty of monitoring in place. So every team, well, you have to imagine every team works on those guys, rows of tables or desks, and every team has a huge screen next to their desks. And on that desk, you have plenty of monitoring, so if something is wrong, well, they notice it. Yeah, it depends on the severity of the issue as well,
Right.
how fast they need to fix it.
Okay, thank you.
Any other questions?
Question was Tom's question. Maybe could